Welcome to calculus class. I have three response questions from college board exam, uh, calculus AB. So given the right triangle picture to the right in here, suppose that A equals 5 feet and C equals 13. Suppose that side A begins to stretch. Side A begins to stretch this way. To stretch. And then side C will change. Side C from here to here will change. So find the rate. So the rate of change of A is 3 feet per minute. Change 3 feet per minute. Find the range of change of angle theta. Theta is changing at the moment when side A equals 12. When side A becomes 12, we want to find the change of angle theta, of course, with respect to the time. Here we go. To do that, so I want you to find all given, collect all given first, given here. So given side A equals 5 feet, side C equals 13 feet, and also we have here the change of side A with respect to the time equals 3 feet per minute. That's what I have here. And also B is constant, remains constant. No change with B. B is constant. That's all given. Okay. What we need to find the change of angle theta with respect to the time. Procedure, how to do that. So find what's missing. We need, like, this data is missing, so we need to collect enough data to find theta. So think about that. If you want to find change of the theta, so we have to find a trig ratio for theta. Okay. We could do it based on A and C, but it would be better to make it with A and B, because B is constant. C is changeable, A is changeable. It's not that good to do it. A, we know it, but B, we don't know it. So we're going to use Pythagorean theorem to find what's missing here. So one of you said, oh, we have A equals 5 and we have C equals 13. Why wouldn't use cosine? We could do that, but it's not going to be perfect because A is changeable and C is changeable too. So what we could do here is to find something related to constant sides. So A with B. Yeah, we could do it A with B. Why we select A? Because we have enough information about A. We have the side A and we have the change of side A after, before and after, and the amount of change. Okay. So let's do that. First, we use Pythagorean theorem that A squared plus B squared equals C squared. Then A is 5, so 5 squared. And B is unknown. C equals 13. Then B squared equals 169 minus 25, which is 144. 144. Then radical both sides. Square root of 144 equals 12. So the missing side B is 12. Let's color it differently. B equals 12 in here. Over here. We finished that. So now we're going to come to the derivative. So we're going to select ratio, relate A with constant side, so A with B, and angle theta. So angle theta, tangent of angle theta equals b over a, right? So let's start from that here. We'll do that here. So tangent of theta equals the opposite side, b over a. That's first. Then solve it for b. B equals, and I'll tell you why. B equals cross multiply a times tangent theta. Okay. Then we're gonna find the derivative. Why I selected b to be in here? Why we isolate b? Because when you find derivative for b, it's constant, and the derivative of constant is 0. So it will help us. We don't have to bring a headache for us by having another side that changeable and find. You're gonna be smart when you choose which ratio you have to go for it. So let's do the derivative first. Derivative of both sides. Derivative of b with respect to the time, and this is constant, then it will be 0. Then derivative of a tangent theta. That's u, that's v. U dash v plus uv dash, product formula. So derivative of first, which is 1, right? But you still have to mention dA with t. Yeah. Derivative of a with respect to the time. Derivative of a is 1, yes, but yeah, it's implicitly we're gonna do dA over dt times tangent theta plus derivative of tangent theta, the second, times the first. So keep a, and derivative of the second is of tangent, which is secant square theta, and what else? Implicitly, we do that with respect to the time, times derivative of theta with respect to the time. And this is the one. This is the one that I needed. This is my target. My target is to solve it. Solve it for d theta with respect to the time. Yeah, this one is my target. Okay. Let's expand it more. So now we're gonna separate d theta with respect to the time. So we'll do that. So we keep the whole chunky stuff here. Even a in secant square theta. Keep it. Then a secant square theta d theta with respect to the time equals, subtract tangent theta dA with dt, move it to the other side, will be negative dA with respect to the time, derivative of a with respect to the time, tangent theta. And remember that I need to solve it for d theta with respect to the time. I need to separate that. So to separate that, continue, we need to get rid of a secant square theta. Just divide it by. So we're going to divide it by a secant square theta. And here's a secant square theta. This will be cancelled out. And d theta with respect to the time left. Equals, left side we have to deal with it. We don't have to simplify that much. Just plug it in what we know. We know dA with respect to the time. It's given. And we know now the tangent of angle. We know ratios. So we could find tangent and secant. Let's do that here. So tangent and secant and dA was derivative of a. So let's do it here on the side. So dA with respect to the time, it's already 3. What else? We need tangent. Tangent of theta, which is b over a, which is 12 over 5. So tangent theta equals 12 over 5. Also, we need secant theta, which is reciprocal of cosine. Cosine is adjacent over hypotenuse, which is 5 over 13. We're going to flip it to be 13 over 5. 13 over 5. If you need to square it, so to square it, just keep it like that. It's better. Yeah. Now we need to plug it in all of that. So d theta with respect to the time equals negative, and substitute for the derivative of a with respect to the time, which is 3 times tangent theta, which is 12 over 5, divide by a. Oh, okay. Do you want to find it when a equals, it's given here, when a equals 12, when a stretched to 12. So this is 12, okay, and secant is 13 over 5. Secant square is 13 over 5 square, or 13 over 5, 13 over 5. That's secant square. Now let's simplify that. So cancel out 5 with 5, and cancel out 12 with 12. Okay, so 5 was 5, and 12 was 12. So what's left here? Negative 3 at the top, divide by 13 times 13 at the bottom, which is 169. Divide by 5. When you divide also by 5, you're going to flip 5 to be negative 3 times 5 over 169, which is negative 15 over 169 rad. If you want to convert it to decimal places, that's fine. So derivative or change of angle theta with respect to the time equals negative 15 over 169. Makes sense. Makes sense because the angle get less and less and less. Once you stretch this side and you expand A and you stretch C, angle theta is getting less and less and less. So it will be negative. I am done for that. I hope you got it. Any question? Just mention that in your YouTube comments. Thank you.